Hello, this will be my first video demonstrating my QB64 source debugger, which I call QDB, and I'll use the same program that I used to demonstrate the Dr. Watson postmortem debugging in this forum thread. I should have just pressed the forward button. There we go. So hopefully you will have watched that other video because it's the same program. Can't type very well today. It's actually doing a lot of the same stuff, but it's just doing it for us where it can. Okay, so I'll try to arrange the windows now. And notice that when I press a key in the debuggy, it loads 2 more DLLs. Anyway, not really that important. So we type question mark for help, and we can type question mark followed by a command name for help on that specific command. So if we type QS, that's for the stat command. If EIP points into a function that has not yet created a stack frame, the interpretation will be wrong. So let's remind ourselves where we are. We're here at the start of the QB main function. That push GBP, that's the first step in creating a stack frame. So if I do a stack trace here, QDB does not know, or QDB's logic for doing the stack trace is not correct in this case. You can see it's listing only one SDL function. That's not right. So if we press F8 to trace, now we're at the first executable line. QB main has had a chance now to set up its stack frame. So if I type S now, it is correct, or it should be correct. You can see there are 2 SDL functions, which if you remember from the Dr. Watson trace, that should be correct. So it's F8 to step through line by line. That's QB or QB64 or QB64 source lines. We're not stepping through, individual instructions or anything. Just the basic source lines. F10 is procedure step, where we're stepping over. If we're at the start of a where we're going to call a function or a sub, we'll just go right through it and come back to whatever function we started from, and the program uses the EBP, the base pointer, to tell when it's back to the same function level that we were at before. And I'll demonstrate breakpoints separately. Hopefully I'll remember not to press F9 because doing so kills the screen capture program, but anyway, I found that out the hard way. Anyway, so F8, F8. You can see we're in the A sub now. We're actually 4B hex bytes into the A sub, and we're on line number 15 in the program. So if I press F8 again, we're in picky. I can actually do a stack trace. Sub A's parameter was 2, had a value of 2. There's the pointer, and there's the value 2. B had a value of 2. Picky has a value of 2. Remind ourselves where we are. By pressing R, it displays the registers, but also either the current basic line, or if we're not on a basic line, say we had pressed escape to suspend it midway through execution, we might be between basic lines. It would then unassemble that instruction. Anyway, so press F8. At this point, when I press F8 from here, we're going to go all the way back to the A sub, so it will print 5 here in the output window, or actually 3. It'll print 3 in the output window when I do that, which is 2 plus 1. So there we are. We're back all the way in sub A, and it's printed 3 in the output window. This next one I'm going to procedure step through with F10. And you notice it's actually stopped at each point. It stopped at each line, but it's automatically continued because EBP was not back to where we started from. So now we're and it printed 5 on the output, the display window. It printed 5. So I'm going to press F8 again, and again, and again. Here, if I do a stack trace, this should look very familiar if you watched the other video. It's basically exactly the same. So if I press F8 again, there we go. Access violation, first chance. The first chance the operating system is giving the debugger a chance to handle it before even or a chance to see it at least before even the handlers, the exception handlers within the program get a chance. The second chance means that the exception handlers within the program, if there are any, didn't handle it, so the debugger is getting a second chance, and there's not really much that can be done at this point. QDB won't allow you to resume the program from here at all, but we can do various other things. We can do a stack trace, and you can see it's still basically the same. We have MSVCRT memmove, and we don't have perimeter information for this here in the automatic stack trace. QDB is getting its information from the map file. That's, the map file tells us the perimeters, so that's how it knows what to do there. But this is just a DLL symbol. We don't have any perimeter information. We could do a raw stack dump. Actually, I'm going to do D ESP. I'm actually going to do DEBP also. Let me see if that works out better. You know what? I don't think that worked out very well. Let's do ESP, which is the stack pointer, and R also. EBP is FE40, FE40. So actually, hold on just a second. I'm sorry. I know it's an offset from EBP. I guess the one's the old EBP. That's probably the return address. So that's the destination. That's the source, and that's the number of bytes. Those are the 3 parameters to memmove. So the only way we can get them is through the raw stack trace, or raw stack dump, I should say. But the others, Func Picky was 6, Func D was 2, Func A was 2. Same as the other video. So, what else can we do here? We've already done those. We can unassemble. If I just type U, it'll unassemble at the current EIP. If I press or type U again, then it just continues unassembling down the road. U EIP to go back there. U EIP minus some arbitrary number to unassemble before that point. And when I do an arbitrary number like that, there's a chance I could be starting the disassembly midway through an instruction, in which case it'll be incorrect until it gets aligned correctly again. What else can I do? I can list the threads. That's not very interesting though at this point. Resolve. That's kind of neat. Oops, I did not spell it correctly. So if I type some arbitrary symbol or arbitrary address, it tries to find whatever symbol is closest before. Basically what we were doing with the map file, but it does it for us. Search is basically the opposite of that. We can type part of a symbol name either from the map file or from a DLL export, and it will search basically everything it knows and list it. and I can search memmove as another example. I think that's kind of neat. It is useful also. And I believe that's... I haven't tried reset actually, but I'll not try that right now. I think that's all I'm going to do here. If I F8 from here, primary thread is not suspended, and actually QDB has ended at this point because it's just not designed to handle that. So to demonstrate breakpoints, I'll go back into it. I think if I'd pressed reset or typed reset, I think it would have just started from the start again without having to recompile it. I think it would have done that. I'm not real sure. I don't remember. But I just wanted to show you what would happen if you continued from that point or tried to. Breakpoints. First I'll demonstrate go. Go is F5, but actually you can put a line number there also. So let's try going to line number 15. So if I type G15, I've gone to line 15. If I type B for breakpoint, then followed by a line number, the line number is optional, but just to demonstrate, I'm going to try line 43. That's not an executable line, so this is what it'll tell you. B43, can't find it. B44, and what it's doing is it's actually matching line numbers from if you've looked at the code that QB64 outputs, there's lots of cases where through the error checking it'll have a function call to evnt with a parameter, and that parameter is a line number. So the program QDB goes through and looks for that basically, and that's how it knows what line number, and then it does its best to match that to a C++ line number, and then it'll do its best to match the C++ line number to a memory address, and there's room for error in both steps. So that's one of the reasons why I don't really trust QDB fully yet, but that's how it's working here. So I've set a breakpoint at line 44, and if I go or F5 from here and it's red, which you'll remember that's what QBasic would do on a breakpoint line, I would press F9, but I can't press F9 because that will kill my screen capture program. So I'll type B without a parameter, and that just toggled. Oops, no, it lists the breakpoint. I guess I would have to press F9 to actually toggle a breakpoint, which I can't do that. So I'll do B44 again, and that should unset it. And that's kind of how that works. And I can press F5 from here and crash it again. Let me see if reset would work. No, it didn't. Sorry. Okay. Well, that concludes this video. And there were 4 bugs I fixed this morning in QDB, so I'll go ahead and upload a new version of QDB. Alright, thanks for watching.